Hello, it's Ms. Pathlin again, and this is part 2 of the Unit 6 practice test video. So number 17, a wildlife biologist tracks the number of wolves in a particular region. Data for 15 months is shown. Use the data to make a frequency table with intervals. All right, so 14 through 17 is our first interval for the number of wolves. So I just go through, count how many have the numbers 14 through 17. So here's 1, 2, 3, 4, 5. 18 through 21. 1, 2, 3. 22 through 25. 1, 2, and 26 through 29. 1, 2, 3, 4, 5. So you're just counting how many numbers are within those intervals. 18. Constellations are made up of more than one star. The table shows the number of stars that make up various constellations. Find the mean, median, mode, and range of the data set. Before we can start finding these statistics, we want to put these numbers in order from least to greatest. So 17, there's another 17, 24, 35, and 49. All right, for the mean, we want to add all of the numbers together and then divide by how many numbers there are. So I do 17 plus 17 plus 24 plus 35 plus 49 divided by, and there are 5 numbers in this data set. When I add those all together, I get 142 divided by 5, which equals 28.4. So on average, there are 28.4 stars in these sets of constellations. For the median, we want to find the middle number. When they're odd, there's going to be an exact amount on each side. So there's 1, 2, 1, 2, 24 is the median. Mode is the number that occurs the most. So in this case, so it's like the number that's repeating the most. In this case, 17 is, so our mode is 17. And the range is the largest number subtracting the smallest number. So for our range, our largest number is 49 minus 17, our smallest number, which equals 32. Number 19, the number of calls answered by a paramedic team over 2 different time periods are given. Use the data to make a box and whisker plot for each set of data. Again, you need to list these numbers from least to greatest consecutively, or not consecutively, that would mean they're exactly after each other, but just from least to greatest. So for this, I see 20 is my smallest number. And it goes 21, 23, there's 2 23s, 2 24s, and 25 and 27. All right, in order to create a box and whisker plot, we have to find the 5-number summary. So you need to, first you can see that our minimum is 20, our maximum is 27. Then I want to find my median of this entire data set, which is your Q2, your quartile 2. So I have 1, 2, 3, 4, 5, 6, 7, 8 numbers. When you have an even amount of numbers, you're going to have to find the average of the 2 middle numbers. So I know there's going to be 4 numbers on each side because half of 8 is 4. So 1, 2, 3, 4. I know it's going to be in between here, and then 1, 2, 3, 4. So I have to find the average of these two numbers by adding them together and dividing by 2. And if I add those together, I get 47 divided by 2, which equals 23.5. So that's my Q2. Another way, like if you see that these numbers are consecutive, 23 and 24, it's going to be right in between those two numbers, 23.5. But do the math if you're not exactly sure. All right, then we need to find the median in the first half. So since there's 4 numbers here, I know it's going to be in between 21 and 23 because it's going to have 2 numbers on each side. Find the average. 21 plus 23 is 44, divided by 2 equals 22. That is your Q1. And then half of the other side, the median of the other side, between 24 and 25, I know that's going to be 24.5 for Q3. All right, now we can make our scatter plot, which now I feel like I ran out of room, but I'm going to make this work. So you want to draw your number line first. Start your number line a little less than the smallest number in your data set. So if 20 is my minimum, I'm going to start at 19, counting by ones. I know it needs to go up to at least 27. Oh, perfect. All right, so then I can put my whiskers at my minimum. Oh, I just messed up. My minimum is not 19. It is 20. So we need to fix that. All right, put it at 20. Maximum is 27. All right, then quartile 1 is at 22. So I'm going to put a line there. Quartile 2 is at 23.5, so I'm going to put it in the middle of 23 and 24. And quartile 3 is 24.5. Draw my box and then connect my whiskers. All right, and the other data set, again, list it from least to greatest. So I have 1, 1, there's 2 1s here. Then I have 2, and then 2 3s, 1 4, and 2 5s, and a 7. All right, so I know my minimum is 1. My maximum is 7. Let's see how many numbers are in this data set. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you have an odd amount, you're going to have the inexact number in the middle. So I know there's going to be 4 on each side. 1, 2, 3, 4. 1, 2, 3, 4. 3 is my Q2. All right, then I need to go and find my Q1 and Q3. So if there's 4 numbers on this side, I know it's going to be in between 1 and 2, which is 1.5 for my Q1. And then again, 4 numbers on the other side, between 5 and 5, which will be 5. If it's the same number, then 5 is your quartile 3. All right, now we're going to make the box and whisker plot for this one. I'm going to start at 1 and go up to at least 7. 1, 2. It's okay if you go a little above 7 though. Or even start at 0. All right, so my whiskers are at my minimum and my maximum. Then I have my quartile 1 is at 1.5. Quartile 2 is at 3. And quartile 3 is at 5. Create my box. And whiskers. The double box plot shows the cost of the top-selling lunch menu items at 2 local restaurants. 20. Identify the quartile that shows the greatest spread for the Red Brick Grill data. All right, so the greatest spread I see is between quartile 3 and the maximum, so that's the upper quartile of the data. So we have the Red Brick Grill here. This I see is the largest region. So that would be the upper quartile. And it is 10 minus 7 because I see the maximum is 10 and then quartile 3 is at 7. So that's a spread of 3. All right, 21. Identify the quartile that shows the greatest spread for Sophie's Cafe data. So here's Sophie's Cafe data. And I see the middle quartile has the greatest spread because like the lower quartile is from the minimum to Q1. That's only 1. Then I see in the middle quartile it goes from 6 to 8. And then from Q3 to the max it's 8 to 9. So 6 to 8 is the largest. So I'm going to say the middle quartile. And that is 8 minus 6, which is a spread of 2. Identify the 5-number summary for each restaurant's data. So we just have to look at where the whiskers are, and in this case, where each point is. So for the Red Brick Grill, the minimum would be that first point, so that's 4. In this case, it's talking about the cost, so $4. 4. Q1 would be this next point, that's at $5. Q2 is this middle point, $6. Q3 would be at 7. So here, if I label it, this is min, Q1, Q2, Q3, and max would be at 10. Then we have Sophie's Cafe. So for the min here, that would be at 5. Q1 would be at 6. Q2, 7. Q3, 8. And the max would be 9. 23, calculate the interquartile range for each restaurant's data. Interquartile range is, so we say IQR for short, and that's Q3 minus Q1. So for Red Brick, Q3 we got 7 minus Q1 5, so that would be a spread of $2 in the interquartile range. And then for Sophie's Cafe, we got 8 for Q3 minus 6 for Q1, which would also be 2. Consider the scatter plots shown below. So we have 5 different scatter plots with different types of correlation. Explain why correlation coefficient of R equals negative 98 hundredths is a better R value than R equals negative 60 hundredths for scatter plot 1. Something that I was telling one of my students yesterday was, if these numbers are hard for you to interpret, maybe it will help to think of them as percentages. So an R value, a correlation coefficient of 1, that's a perfect or a negative 1. That's a perfect correlation. Perfect or the strongest correlation you can have. And when there's absolutely no, so that means all the points are going to, if you drew a line, all of the points would be touching the line. So if I had a line, all of my data points would be exactly on that line. And then if r equals 0, that's absolutely no correlation. So all of my data points, if I had a graph, would just be all over the place, random. There's no line I could put there to show any correlation. So if the decimal values are close to 1, that's going to be stronger, or -1. If they're closer to 0, that's going to be a weaker correlation, or no correlation. So it might help to think of it as a percentage. Think of 1 or -1 like 100%, or a -100%. And think of 0 as 0%. So when I look at these values, -0.98, if I move that decimal to the right, it's -98%. -98% is pretty close to -100%. And then -0.60, that would be -60%. So that's still in the upper half, close. I mean, it's not close to 100%, but that would be a weaker relationship. You know, you can even compare it to your grades. 100% is the best grade you can get. It's perfect. So -98%. So when it's negative, we're talking about a negative correlation. So like scatter plot 1 is negative, these points are decreasing. Scatter plot 3 is negative because the points are decreasing. So that's when we have a negative R value. So if I just look at the number 98%, I know that's going to be a very strong negative correlation. Whereas 60%, think of, you know, when you get a 60%, that's not a very good grade. You know, that's failing, and that's going to be a moderate to weak relationship. So if we're looking at scatter plot 1, this one, you know, looking at all of my scatter plots, this one has a stronger correlation. So all these points, if I drew a line, they're going to be pretty close to the line. So I'm going to explain. It's a stronger negative correlation because r equals -0.98 is closer to 1, or closer to -1, and the data points are close to the linear model. 25. Explain why a correlation coefficient of r equals 0 is a better r value than r equals 0.92 for scatter plot 2. So again, thinking of percent, 0 would be 0%, 0.92 would be 92%. Well, 92%, that's close to 100%. That's a pretty good grade. It's a high B. Or, yeah, that's a high B. 0%, that's absolutely the lowest. So looking at scatter plot 2, I can't draw a line. If I drew a positive line, linear line, all the points are kind of spread out all over the graph. If I drew a negative line, like nothing really works with this data. So that would have no correlation. There is no correlation. All the points are random and spread out r equals 0.92 would show a strong positive correlation. So that does not fit. The data. 26. Explain why a correlation coefficient of r equals -0.75 is a better r value than r equals -0.95 for scatter plot 3. So So going up to scatter plot 3. So they're both negative. I know that this data is showing decreasing. And if I compare to scatter plot 1, these data points are a lot closer to the line than on scatter plot 3. They're still a moderate, I would say. So again, thinking of percentage, this is like negative 75% compared to negative 95%. So I know that they're a little further for the line. Negative 75% is going to be a better model, better correlation coefficient. The data points have a moderate negative correlation. So R equals negative 0.75 is a better representation. 27, explain why a correlation coefficient of R equals 0.88 is a better R value than R equals negative 0.8 for scatter plot 4. So here I'm seeing this one's positive, 80%, 88%, this one's negative. So I just have to go and look at what type of correlation scatter plot 4 has. This one has a positive correlation, and it's pretty strong. So that one is definitely going to be R equals 0.88% because it's showing an increasing set of data. The data points have an upward trend or are increasing. So the R value must be positive. All right, last one. Explain why a correlation coefficient of R equals 0.75 is a better R value than R equals negative 0.95 for scatter plot 5. Again, one is positive, one is negative. So let's go to scatter plot 5. I see that this data is also increasing. So, and it's more moderate. The points are not super close to the line. So that would make R equals 0.75 a better fit. Scatter plot 5 has an increasing, moderately positive correlation. So the R value must be positive and not as close to 1. All right, that completes the practice test. I know that you will do great as long as you prepare and study. This is your last test of the algebra semester, so rock this, you got this, stay positive, and I hope everyone has a great rest of your day and week.